In this video, we're going to go over how to factor a sum and difference of two cubes. To factor a sum of two cubes, well, let's talk about what this means first. Sum means that you are adding, and two cubes means that you have two numbers that are perfect cubes. So when that happens, this is the rule that you need to follow for factoring. There's no fancy trick or anything. You just need to know this rule. So if I'm looking at this first example, first you want to check to see if you have a sum of two cubes. First, you have a sum, so that's good. And then we need to figure out what's being cubed for each of the terms. So x is being cubed in x cubed, and 3 is being cubed with 27. So that's how you know what your a and b are. In this case, a is x and b is 3. And we're just going to apply that using this rule that we are given here. So my first part of the rule is a plus b. So that would be x plus 3 times a squared. X squared is just x squared minus a times b. 3 or x times 3 is 3x plus b squared. 3 squared is 9. Once you do that, you want to check to see if you have factored completely. X plus 3 is factored completely. I know that because it's linear. Remember, linear means your highest exponent is 1 for your variable. So here x is 1 for my exponent. So that one's factored completely. So I can go ahead and bring down my x plus 3. For the second one, I have a quadratic. I know that because your highest exponent is 2. When your factor is not linear, you want to double check to make sure that it's not factorable. If I were to do the area model for this, I would be looking for factors of 9 that add to -3. No such factors exist. So this is my final answer. Let's try this again, but now let's look at a difference of two cubes. So here, a difference means that you are subtracting two cubes. Again, this is the rule that we're going to be following. Unfortunately, there's no special trick. You just need to know this rule. So on this example, I have 8x cubed minus 1. I need to figure out what is being cubed in this first term and what is being cubed in the second term. Well, it looks like 2x is being cubed because 2 cubed is 8 and x cubed is x cubed. In my second term, it looks like 1 is being cubed because 1 cubed is 1. So 2x is going to be a and 1 is going to be b. So let's factor that. We are going to be using this rule over here to be able to factor this. So first I have a minus b. So that's going to be 2x minus 1. My second term, I have a squared. So I need to do 2x squared. Let me write this down over here. 2x squared. Well, if I use my exponent properties, that would mean I would have 2 squared times x squared, which would give me 4x squared. Plus, I have a times b. 2x times 1 is 2x. Plus b squared. 1 squared is 1. Now that we have factored the difference of two cubes, we want to check to see if we have factored completely. This first term is linear, so I know that that one is factored completely. If I were to try to factor this one, I would be looking for factors of 4 that add to 2. There are no such factors, so I know that this one is factored completely. So that would be my answer. And that is how you factor a difference of two cubes and a sum of two cubes.